For lesson 3 in unit 3, we're going to focus on rotations. This again, we're just going to rotate a figure. It will not change its dimensions at all. It is a rigid motion. So we will maintain angle measures and side lengths in our triangles or quadrilaterals or whatever it is that we are rotating. The goal is to make sure that we can draw and describe a rotation. So the drawing of it should be I can follow the directions. The describing of it is I can work it backwards to figure out how this was rotated in the coordinate plane. And so again, here's just a ton of information about how we execute rotations in the coordinate plane. Now, in order to just make this a little more manageable for us kind of initially here, we're going to focus on rotating on every 90-degree interval and exclusively about the origin. All right, but we can do these rotations by any angle measure around any point in the coordinate plane. And so we're going to focus really our energy on 3 rotations really about the origin. And so that's going to be just kind of narrowing down our focus. Try to have all this information, including how we are going to be writing our rules. The rotation is this transformation. So we'll do a rotation lowercase r with a certain amount of degrees around a certain point of, maybe it's triangle ABC, that gives us triangle A prime, B prime, C prime. So we're going to have our rules look like that, but we have a lowercase r here for rotation, whereas we had an uppercase r for reflection. So read through this information here. We are taking this picture, triangle ABC, and we are rotating it a certain amount of degrees. It maintains its size, its shape. It just, again, changes its orientation. And so we're not rotating it on one of its corners necessarily, but rotating it from a point that is maybe removed from that triangle, all right, or whatever shape it is that we are rotating, all right? And so I'll have a little visual for us in class on what that may look like if we're rotating about a separate point, and that might be useful. So the way that we are going to do that is we're going to start by drawing our segment that connects the point that we are rotating to the point of rotation, the center of rotation. Then we use our protractors to measure a certain amount of degrees from that location, circa or centered on point P, and then we will mark PA prime in the same distance as PA so that we can know where that new point is. So I know this might look a little bit confusing here, so I'm going to go back a slide. And essentially what we're doing is we are measuring the angle from point P here and making a little hash mark or whatever, and then we draw through that hash mark the same length as PA. We draw where A prime will be located. All right? So again, that is how we would do this if we were doing ruler, compass, constructions, protractor as well to measure out these angles. But in order to make this task a lot more manageable for us kind of initially, is we are going to focus on rotating in 90-degree increments. All right, so we're going to focus on what does it look like to rotate a point by 90 degrees about the origin, what does it look like to rotate a point 180 degrees about the origin, and what does it look like to rotate a point 270 degrees about the origin. All right, so that's every 90 degrees. So we're going to get these relationships down because this is maybe a harder thing to understand from a conceptual level, and maybe it's easier to know what these recipes are in order to get from our original xy to our new xy. You're going to notice in the notation that you're using here is very particular, lowercase r, parentheses, 90 degrees, comma, this is a O for the origin, rotation 180 degrees about the origin, 270 about the origin. When we're rotating point xy by 90 degrees, essentially the way that we do that is we swap the x and the y and we change the sign on the y, all right? So this maintains the same number, this changes opposite, but we change their location in the x comma y. So now we have the opposite of the y value, right? This was 1 comma 2, and now it is -2 comma 1. We switch their places and we change the sign on the original y value, right? With the rotating 180 degrees, we are doing both the opposite of x, comma, the opposite of y. All right, so this was 1, 2, now it's -1, -2. With the rotating 270 degrees point xy, we're going to change it to y, comma, the opposite of x. So very similar to what we do here, we still switch them, right? We're still switching it, but then we're changing the sign only on the former x value, the new y value. So let's go ahead and try to execute this. Remember, our rotation 90 degrees means that we're going to take our x comma y is going to become the opposite of y comma x. That's how things are going to change. So for this picture, if I want to rotate this 90 degrees, this quadrilateral ABCD, then for each of these x comma y's, I'm going to, do I have those typed in there? I don't have them typed in here. I'm going to take each of these x comma y's and I'm going to change them to their new format. So originally A here is the point 1, 2, 3, comma 1, 2, 3, 4, 5. B is at the point 1, comma 7. C is the point -2, comma 4. And D is the point 2, comma 1. So when I rotate these 90 degrees, remember I'm switching the x and the y. I'm switching the x and the y. Oh, whoops, this is -1. But then I'm changing the sign of the y term. So if it's positive, it's going to become negative. If it's negative, it's going to become positive. And so now when we plot these new points for what are going to be A prime, B prime, C prime, and D prime, we're going to notice that this figure has been rotated 90 degrees about the origin. All right, about the origin. So I'm going to do this one in red. So we'll have -5, 3. We'll have -7, 1. We're going to have -4, -2. And then 1, 2. Now when I connect these dots, it's going to look a little bit funny, but you're going to notice that we have rotated this a little bit to the left, turning it as it goes, so that now instead of this seemingly, I know it's a trapezoid, but instead of this kind of pointing up in this direction, it's going to now be pointed, instead of pointing up, it's going to be pointing 90 degrees to the left. It's going to be pointing left. We always do our rotations counterclockwise. Now, if you were to look closely, you should be able to tell, and you can do this on your own paper, you can measure, whoops, B prime, C prime, and B prime, C prime is going to be the same length as BC. And what we'll notice is that we took this thing and we rotated it 90 degrees counterclockwise, okay? If we were to measure out segment AD, it would be the same as A prime, D prime. If we measured these angles, if we had a protractor or another measuring tool, we would find that these angles are congruent, that these angles are congruent, these angles congruent, and those angles congruent. So it maintains its size, it maintains its shape, it just changes its orientation. I want for you to do this one. You get to take those same x comma y's of the original picture, but now you're going to rotate it 180 degrees. You can draw it on the same coordinate grid if you would like. Obviously, it's going to need to go a little bit lower, but go ahead and you do this one, example 2b. All right, so for the punchline here, this is sort of a challenging item. What I would like for you to do is do your best job trying to draw these two figures. They should be congruent to each other, and one is obviously a rotation of the other. We started with, I guess we start with JKLM and we rotate it back this way, or we're rotating it all the way around that direction, all right? And so the way that we're going to explore this is to recognize that really what we've got happening is a pair of reflections. That if we have two reflections that go through this point of rotation, then we can model that, that this rotation is simply a composition of reflections. All right, so here's what we're going to do. We're going to go from this one to that one, and we're going to recognize that, that I can draw my first line anywhere that I want to, all right? And so I would encourage you to actually hold off on your version, and I would like for yours to be different than mine. All right? So if you can do yours different than mine, that would be awesome. But I'm just going to draw a line segment through point T. Now, if I reflect this over that line, we're going to do what we did in lesson 1. So we can measure each one of these things out and recognize that this is about 10 centimeters. All right, so here's going to be my K prime. If I do this with J, kind of the same deal. I've got 14 and a half, so 14.5 for my L prime. Whoops, oh, that's J prime. For L, we're gonna try our best to measure that. Looks like for me, I've got, mine's different than yours is gonna look. I'm gonna do 80, where are we? 86 and change. So we're gonna go forward and change. Right there's gonna be L prime. And then for our last one, which is off just a smidge there, we got 10, 20, I got about 25, a little closer, 10, 20, and 5. Now, if I draw this in red, this should be very similar to, hopefully I did a good enough job that it's congruent to the picture that we had. All right, so this picture and this picture ought to be congruent to each other. It's pretty close. I did a reflection and maybe did it a little sloppily. But what we should notice is that these are also a reflection of each other. And so I can do another line of reflection that cuts this distance in half, right? That I could find the halfway point here. If I find the midpoint of that segment, which is going to be about right there, if I connect that to here, then I should notice and I should believe that I've got another line of reflection. All right, now if I'm doing this on the coordinate plane, then I can draw this line wherever I want to, and then I would just have to find out where is the line of reflection for this other one. So I can make this one up, and then I can find what that one is. Now for you, you might want to draw this a little bit differently, but you can see that if I reflect this over the red line and then reflect this over the blue line, then I'm going to end up at the same rotation as I would moving this figure over to that figure. And so this reflection over the red line, I'm going to call this just line L, and I'll call this one line M. How's that? So this is the reflection, the reflection over line M of the reflection over line L of, not triangle, of this quadrilateral JKLM gives us WXYZ. And let's actually just make sure that those line up here because J goes with W. Okay, good. K goes with X. Y goes with L. Okay, good. So those all line up. But it's the reflection over line M of the reflection over line L of JKLM gives us WXYZ. And so what I want for you to try is what would happen if, now this is the part that you do, what would happen if you draw your line in a different place than me? For example, what if you drew your line of reflection a lot closer to that figure? How would you draw your next line for reflecting? So that's the one that I want for you to try to do this differently than I did. And so maybe you're going to draw your line a little bit different. Maybe yours is going to be like that blue line that I drew or something from there. So reflect that and then reflect it again to map back to where we are supposed to be. I'd love to see how well you do with that. All right, so again, rotations are simply compositions of reflections. That's kind of the punchline there. But our focus is going to be working with those rotations in the coordinate plane about the origin.